In this video we're going to have a look at linear inequations. So we've got our mathematical symbols less than and greater than. We've also got these less than or equal to and greater than or equal to. So just as a recap, our inequations symbols basically the pointy part points to the smaller number. So if we're looking for 5 and 10, we can say 5 is the smaller number, so it points to the 5. Okay, this statement says 5 is less than 10. Less than or equal to, well, 5 less than or equal to 10 is true, but you can also say something like 10 is also less than or equal to, and it's because of this equal to. 10 is equal to 10, so this statement is actually true as well. When we're talking about greater than, same rule applies. This time I'm going to write 10 and 5, except this time it's still going to point to the smaller number. 10 is greater than 5. 5 is the smaller number, so it points towards the 5. So that's how we would read this statement. And similarly, greater than or equal to, so 10 is greater than or equal to 5. But we can also say 5 is greater than or equal to 5. That's also true as well. So just some terminology there, just as a bit of a recap. What we're going to start doing is putting numbers or variables on a number line. We've been talking about x quite a lot, and usually we've only got one solution for x. So if you've got an equation like 3x equals 12, solving that we would find if we divide by 3, x would be equal to 4. That's only one solution. Now we're going to be talking about what happens when x has multiple solutions. So when we have a number, let's say we've got the variable a. Okay, a is just an integer, so that's just like 1, 2, 3, and so on. Okay, so it's going to represent some number. If I've got x as a variable, x is going to have every number that's less than a. So if a was a 3, I would say x is actually every number below 3, okay, less than 3. So on a number line, let's call a on our number line. We don't know what it is, so we'll just put it here as a. If we're saying x is less than that number, we're going to have every number less than a. Okay, so as a line, we're just going to draw an arrow indicating every number to the left of it. Now, we're not including a, so we use this open circle. Right, an open circle on a number line indicates it's going to get very close to a, but it's not including. Whereas if we're talking about x less than or equal to a, okay, same spot at a, except this time we're going to use a closed circle because we're actually going to include a itself. And similarly, if we're talking about greater than, if we've got a over here and we're talking about x is going to be every number greater than a, so a is here, it's greater than, so it's open circle, and it's going to be every number to the right of it. It's every number greater than a. And again, if we've got greater than or equal to, this time we just use a closed circle, okay, at the point a. So this line, this arrow that we draw, this is actually representing x. Okay, it's showing that we've got multiple values for x. So for some examples, we've got a number line, okay, 1, 2, 3, and 4, and I'm going to draw the values of x as a line or an arrow. Okay, so we're actually going to write the inequation for this situation. We're talking about x, so we'll put x there, and we're saying, oh, x is every number greater than 2. The arrow is pointing to the right, and the dot is above 2. So this one here actually says x is going to be greater than 2. It's every number greater than 2. And it's an open circle, so we don't include it. Okay, we just say greater than. If we're talking about values between 2 points, a situation might look like this. We've got a dot above -3, and we've got a dot above 0. And this one's an open circle. Okay, slightly different, it's just that x is going to be between 2 points. So I'm going to put x in the middle. If you've got two dots, it means it's going to be in between 2 points. X, I'm just going to put the first one here. We've got -3 on the left. Okay, x is going to be greater than -3. That's what we're kind of talking about. We can actually write it in an opposite way. Okay, remember, x is the larger number, so the arrow is actually going to point towards the smaller number. Okay, because x is actually this line here. Okay, it's to the right of that number, so therefore this number here is the smaller one. Okay, so we put the arrow pointing towards the smaller one. And it's a closed circle, so make sure we include our equal sign in there. And when we look at the other number, the one that's above 0, I'm going to put 0 on the right hand side here. 0 is actually the larger number. 0 is the larger number, so our inequality will point towards the smaller one, which is our x. So this time we have an arrow that points towards x. So it's slightly different. As you can see, we've got two inequalities in the same equation. And that just indicates it between 2 points. And just as a recap, if you've got less than but not including, okay, we'll call that an open circle. All right, less than or equal to, we'll call closed circle. All right, so open circle, not including, closed circle, including. Because it's very important when we're talking about writing out inequalities on a number line. A couple more examples. Let's say we actually start with our equation. So we've got 3x plus 4 greater than 13. I want to actually be able to draw that on a number line. Now, there's not much I can do with this at the moment because I don't know what x represents. I've got 3x plus 4. It's almost like solving an equation with just an equal sign. So that's what we're going to do. We're just going to treat this greater than symbol as an equal sign. And just like before in our previous sections, we're going to do some backtracking. So 3 and x. So I multiply by 3, add 4. So going backwards, I subtract 4 first. So I get 3x equal to 13 minus 4, which is 9. And then I need to divide by 3 to get rid of that 3. Alright, and I would find that x is equal to 3. Now that's when we're talking about normal equations. But because we started with this inequation, okay, this greater than, instead of x equals 3, I'm actually just going to say x is greater than 3. Alright, so at the end I just replace whatever I started with. Now I can draw a number line and put some dots in. Okay, so I've got 0, 1, 2, 3, 4, and I'll go 5 there. First thing I say is I've got a greater than symbol. Okay, greater than, it's not including, so I'm going to start with an open circle. So I find where 3 is, put an open circle there, and then it's going to be every number after 3. Okay, x is the larger number, pointing towards 3, so it's going to be everything on the right. So I'm going to draw an arrow that shows everything on the right. Alright, so that's how we kind of write these inequations. It's a bit of solving first, and then we're able to use our number line. Alright, let's have a look at example 4. We've got 4 minus x on 3 less than or equal to 6. This time I'm just going to keep this symbol in here. Okay, but in my mind I'm just treating it exactly the same as an equal sign when we're dealing with equations. So this 4 has a positive sign in front of it, okay, or an addition. So that's probably the first thing I'm going to do, is do the opposite to backtrack. So minus 4 on both sides, minus x on 3 less than or equal to 6 minus 4, we get 2. So that's fine. This fraction divided 3, okay, I'm going to times it by 3. So minus x less than or equal to 6. Now if minus x is less than or equal to 6, what I can actually say is if I multiply both sides by -1, that'll get rid of that minus sign. Except when I'm actually solving inequations, if I'm multiplying or dividing by a negative number, I need to swap over the sign. So instead of it being a less than or equal to, it now becomes a greater than or equal to. So you flip the signs when multiplying or dividing by a negative. Alright, so it started with a less than or equal to, I multiplied by -1, so I flip that sign. So now it becomes x greater than or equal to -6. So when I can put my number line down, okay, and put my numbers in, I'm going to start at -6, -5, -4, -3, and so on. And I start at -6. Okay, it's greater than or equal to, so it's a closed circle, and it's going to be every number to the right of that. Okay, x is the larger number, so it's to the right. Alright, so the key point here is if you are multiplying or dividing by a negative, make sure you flip the sign. Final example, we've got x's on both sides, just like our solving equations. If we've got x's on both sides, I'd probably get rid of those first. So -x minus x, or -3x minus 3x, gets rid of those two. 6x minus 3x gives me 3x, and I've got that -4. Now don't get confused, if you're subtracting a negative number, or if you're subtracting something, it doesn't flip the sign. It only works when you're multiplying or dividing. So just keep that in mind. So I don't need to flip this around because I haven't multiplied or divided by a negative. Okay, I've got 2 greater than 3x take 4. I'm going to add this 4 to get rid of that one. So I get 6 greater than 3x. Again, haven't multiplied or divided by negative, so that's all fine. 3x, I'll get rid of that by dividing by 3. 6 divided 3 is 2, so 2 is greater than x. Alright, on my number line, I need to write this in equation. So I've got 0, 1, 2, 3, and 4. Okay, 2 is the number I'm interested in. It's going to be an open circle. Now 2 is the larger number. Okay, the arrow is pointing towards x. So x is every number smaller than 2. So it's actually all of these numbers. Okay, it's to the left of it. Okay, 2 greater than x. Well, that's the same as saying x is less than 2. Okay, so you can change them up depending on how you read it. 2 is greater than x, or x is less than 2. It's the same kind of equation. So all the numbers to the left of 2, open circle because we're not including 2 itself. So that's all we're looking for in linear inequations, and now we can have a go at some problems ourselves.